All right, so to find a point that's root 2 away from -1, comma 5, um, there's actually an infinite amount of answers because the definition of a circle is the set of all points that are equidistant from a fixed point. So that's like the center of the circle. So technically you could make a circle with the center -1, comma 5. And then any point on this circle is going to be like root 2 away from there. So the answer key gives 4 like nice whole number answers, but there are easier answers than the whole number answers. So you could just move up 0.2 units from that, and you have the point -1, comma 5 plus root 2. All right, you can move to the right root 2, so you -1 plus root 2, comma 5. All right, you can move down root 2, so like -1, comma 5 minus root 2. And if you want to put these as decimals, you can, but it's usually good to leave it exact. Right? Or you can move to the left. And if you think of transformations in geometry, if you want to move to the left, you subtract from the x coordinate. If you want to move to the, it's root 2. I did root 5 over here, sorry. If you want to, root 2. If you want to move to the right, you add root 2 to the x coordinate. If you want to move up, you add to the y coordinate. If you want to move down, you add to the, so you subtract from the y coordinate. So it'd be minus root 2, comma 5. All right, so those are 4 answers. But I might ask you to find points that have like nice round numbers. So you could think of the Pythagorean theorem as another way, and I'll show you a third way. But you could figure that if we move like 1 this way, so 1 to the right and then 1 up, all right, this distance here is going to be root 2 because 1 squared plus 1 squared is equal to root 2 squared, right? They're both equal to 2. So because like 1 squared plus 1 squared square rooted, if you think of the Pythagorean theorem, a squared plus b squared equals c squared, would give you root 2 for the hypotenuse. You could also just move like up and down or left and right 1 unit to get your point. So you can move like 1 right, 1 up, so you're at 0, comma 6. You can move 1 right and 1 down, so you're at 0, comma 4. You can move 1 left and 1 down, so you're at -2, comma 4. You can move 1 left and up 1, so you're at -2, comma 6. Um, and then the other way would just be to like just use the distance formula. So take like the distance formula is the square root of the change in x squared plus the change in y squared equals the distance. So if you plug everything you know into the distance formula, so I'm just going to wipe that clean. If I use the distance formula here, so the change in x would be, so like x minus -1 squared plus y minus 5 squared equals root 2 squared. And then you could solve that out. Well, this would be under the radical. And then you solve that. So like you'd square both sides, get rid of the radical. So you get like a 2 here, and that cancels out. And then you get x plus 1 squared plus y minus 5 squared. And then if you could find any x and y value that like makes this true, then it would satisfy these conditions. So like, you're just trying to make 2. So if you make that a 0 and like that a 6, then you get 1 squared plus 1 squared is equal to 2, which is true. Um, um, yeah, like put it like solve for x or y and put it in point slope formula. Is that so? The thing is, when you multiply this out, you're gonna have, it gets kind of messy where you have like 2 variables and one's squared and one's just x. And the reason why that happens is because there's really an infinite amount of answers. Because if you think back to what we talked about at the beginning, like there's an infinite amount of points that's root 2 away from -1, comma 5. So Yeah, you could definitely do that, but you have to consider that not every value would work for y. So there are an infinite amount of things you could plug in for y, but like if you plug in like -5 for y, like that's too far away from this point to work here. So as long as you plug in a point that's like close enough, that's like a y value in between like the top and the bottom of the circle, then it would work that way. All right.